Hey everyone, welcome to the mid-unit 6 review. I'm going to do everything on the we do side, you do everything on the you do side, and with that being said, let's get started. The first two problems are just simply addition and subtraction. All I want you to do is just combine like terms. Don't change the exponents at all, just match it up with the exponents. So 7x to the fourth can add to 3x to the fourth. And by the way, plus signs, there's nothing to distribute for a plus sign. It is not going to flip any signs. So the parentheses don't even matter. Okay, so do 7x to the fourth plus 3x to the fourth, because those are like terms because they have the same power. So 7 plus 3 is 10. So I have 10x to the fourth. Next I have negative 5x and then a minus 3. But look over here. I have these two terms. These are bigger powers than negative 5x, right? So there's nothing over here to add to these two. So these two are pretty much on their own. So I'm going to put minus 5x to the third, and then I'll write minus 1x squared, okay? And then I will talk about this minus 5x, and then I compare that with nothing over here. So minus 5x. And looks like I can do minus 3. I'll underline that 5 times because it'll be our fifth term. 1, 2, 3, 4, 5. It can combine with that minus 4. So that makes minus 7. So, kind of a colorful answer. I wanted to color code everything as well as with the dash marks. That's our final answer right there. Now, if it is a subtraction problem, you must distribute or else you will get the wrong answer. And so this is going to be minus 3x to the fourth plus 5x to the third plus 1x squared and plus 4. These other signs just say exactly the same. 7x to the fourth minus 5x minus 3. All right? So let's combine like terms. We have 7x to the fourth minus 3x to the fourth, so that makes 4x to the fourth. The next thing to come would be that plus 5x to the third plus 1x squared. And then I can do the minus 5x. Right, and the last thing I can do is minus 3 and plus 4. So that'll just add to get a 1. And yeah, so that's my final answer, because this didn't have any like term to combine with, and neither did these two, just like in the previous example. If you notice, it was the same numbers, just one was a plus and one was a minus. So that's how they're different. All right, hope that helped. Number 3. Basically, there's no special trick to this. Just distribute, multiply the big numbers, add the little numbers, add your powers. So do 2 times 3, that's 6, and then do 2 plus 2, and that's 4. So x squared times x squared is x to the fourth. Now do 2x squared times a negative 4x, so 2 times negative 4 is negative 8. X squared times x, that will be power of 2 plus power of 1. Which is power of 3. And then you have 2x squared times 5, so that's just simply 10x squared. And then we have to do x now to 3x squared, negative 4x, and 5. All right? So I have x times 3x squared, so that'll be plus 3x to the third. X times negative 4x is negative 4x squared, because power of 1 plus power of 1 is power of 2. And then x times 5 is 5x. And now we have to do negative 2 times 3x squared, negative 2 times negative 4x, and negative 2 times 5. So that's going to be negative 2 times 3x squared is negative 6x squared. I'm just going to write that right here. Negative 2 times negative 4x is negative 8x. And negative 2 times negative 5 would make negative 10. All right? So now we need to combine our like terms. So I have 6x to the fourth. That's the only thing with the fourth power. Now I look at the things with the third power. So negative 8x to the third plus 3x to the third. That'll make negative 5x to the third. And then I have 10x squared, and then these two. So I have 10x squared minus 4, so that's 6x squared. Minus 6 is 0x squared. So sure, you could write plus 0x squared, but I guarantee you, if it's a multiple choice question, you will not see the plus 0x squared, so I'm just going to erase that. I'm going to move on to the plus 5x minus 8x. So I have a 5 minus 8, that's going to make a negative 3x. And then I have that minus 10 all by itself. That makes that my final answer right there. Whoops, what happened here? There we go. All right, so number 4 is a pretty similar problem. I'm going to do x to the third times 2x squared. So I'm going to add those powers. That's going to make 2x to the fifth. Please don't multiply those powers. You only multiply powers when you raise a power to another power, and that's not what's happening here. So next I have to do x to the third times the negative 3x, so that'll go up by a power of 1, so negative 3x to the fourth. And then I have negative 3 times 2x squared, so that'll make negative 6x squared. Negative 3 times negative 3x is positive 9x. Are there any like terms to combine? Doesn't look like it. Power of 5, power of 4, power of 2, power of 1. No like terms to combine. Therefore, this must be my final answer. And that's it for number 4. So number 5 would take a really long time to do if you didn't have the formula. But fortunately, we do have the formula. I copied and pasted this from our notes. So I'm going to look at the minus 1 right there. And when you look at the minus 1, it's taking into account the negatives already. So just use 2x for A and a 3 for B. Don't use a negative 3 for B because, like I said, the formula itself takes care of the negatives. All right? So I'm just going to plug in a 2x every time I see an A and a positive 3 every time I see a B, and then make sure I write down these minus signs there. Okay, so a to the third would be a 2x to the third minus 3a squared b minus 3a squared, 2x squared. Make sure, since a is more than one term, you use parentheses. That's very important, okay? And then times b would be times 3. And then 3ab squared, 2x is a, and then b squared would be 3. Every time I plug in a and b, I just use parentheses anyway. It couldn't hurt. But the reason why you want to use parentheses around like something like 2x is because you're going to do 2 to the power of 2 and x to the power of 2, all right? So that this front number is going to change. And then back to this, minus b to the third minus 3 to the third. So I'm going to do 2x to the third. So I'm going to do 2 to the third. That's 2 times 2 times 2. That's going to be 8. And so I'll have 8x to the third minus, and then I have to do 2 squared, that's 4, times negative 3, that's negative 12, times positive 3, that'll make a negative 36. And then I have that x squared. And then I have to do 3 times 2x, that's 6x. What's 3 squared? That's 9. So 9 times 6x would make 54x. And then minus 3 to the third power. 3 times 3 is 9. 9 times 3 is 27. So minus 27. And that is the final answer. So if it's positive, you have even less to worry about, but everything's positive. If it's negative, like I said, just use the number. Don't worry about the negative. Don't plug in a negative 3 because the negatives are being taken care of in the formula. So I just wanted to say that one more time. Let's move on to number 6. Okay, number 6 uses synthetic division. So synthetic division, you have to do 2 things. For one, you have this k value, and it's just the opposite sign. So if it says x minus 6, then k is positive 6, not negative 6. So you're going to write down a 6 here, and then you're going to draw this L thingy. And then you're going to bring down the coefficients. And if it skips anything, you put a 0. But 4, 3, 2, 1, nothing, there's no zeros to put. But if it went like power 4 and then it skipped to power 2, I'd have like a 0x to the third power. And then for more on that, just look at the synthetic division notes video. So I have 1x to the fourth minus 5x to the third minus 8x squared plus 13x. So if it's plus, you just have to write 13. And then minus 12. So this is what I mean by just write the coefficients. Don't write any letters. If it's minus, write it as a negative. If it's plus, just write it as a positive number. And so that first number always gets brought down. And then we're going to multiply. I'm going to do 1 times 6. That's going to be 6. So we're going to add that together. What's negative 5 plus 6? Oh, that's going to be positive 1. So now I'll do positive 1 times 6. That's going to make 6 again, right? So negative 8 plus 6 is negative 2. And I'll take negative 2 and multiply it times 6. That'll make negative 12. And so I'm going to add that. 13 plus negative 12 is positive 1. 1 times 6 is, let me draw my arrow. 1 times 6 is 6. So negative 12 plus 6 is negative 6. And so what you do is your answer goes down by a power of 1. So I started with x to the fourth, so my answer will start with x to the third. So I have x to the third, and then it says 1, 1, negative 2. So 1x to the third plus 1x squared minus 2x, and then plus 1. And then that last number is your remainder. So I'm going to write minus 6 over, and then don't write it over 6, since that was your number here. Just write it over this, your x minus 6, because synthetic division is a shortcut method, okay? So that's why it looks so weird. It's because it's a shortcut method. So, yeah, last number is always the remainder, and, yeah, your answer will start with 1 lower power. And that's pretty much it for synthetic division. Number 7 is evaluate using synthetic division. So you don't flip the sign, you just put the negative 2 there, and then you carry down the coefficients, 5, 3, negative 6, 11. See, it didn't skip anything again. So I bring down the 5, and I say, what's 5 times negative 2? That'll make negative 10. So what's 3 plus negative 10? Negative 7. So what's negative 7 times negative 2? Positive 14. So what's negative 6 plus 14? 8. What's 8 times negative 2? Negative 16. What's 11 plus negative 16? Negative 5. What's negative 5 times negative 2? Positive 10. So what is negative 10 plus positive 10? 0. So when you evaluate, the last number is your answer. And so my answer is 0. So that's why I circled it. So yeah, that's it. You can always check by plugging in the number. 5 times negative 2 to the fourth plus 3 times negative 2 to the third minus 6 times negative 2 squared plus 11 times negative 2 minus 10. You would type that into the calculator, it'd tell you it's 0, and so you know you did it right. But hey, if I ask you to show work to evaluate, that's what you do. So yeah, it's much simpler to evaluate. Well, really, you're just skipping this final step of writing that answer. But yeah, these last two, long division, I'm going to do in the calculator, so please stay tuned for part 2. Thanks for watching. Bye.